Welcome to Coffee and Code. This is Mark Franks, your host. I'm with Acumatica. We have 21 participants. I've been asking Robert and others to have a Coffee and Code around the topic of conditional compilation and branch management. So here we are, about 6 months down the road, finally having that conversation. And I'm excited about it because I think there's a lot to learn about people's different approaches to branch management and version control and conditional compilation. And I think it's a really great topic to discuss. And I can tell by there's 21 people on the call that we're probably getting about 5 or 8 more people than we normally do. So it's good to see a number of people join today. So with that, I'm going to hand this over to Robert first, just to be able to talk about what conditional compilation is, and then we'll have a discussion about branch management, and we'll have some people, like I said, this is just really an informal discussion, extemporaneous, if you will, to use Robert's word, and excited to see how the conversation goes. So Robert, why don't you just give a definition of what conditional compilation is?
So how about we just start with kind of the history of why we wanted to have this session in the first place.
Sure.
A lot of this came out of our surveys involvement, and in surveys we've needed to manage various different versions of the survey's product. One of the things that I've been successful using in the coding that I do is using a topic called conditional compilation. So it it was a very hot topic. We have people coming from all different sides of the um, argument, if you want to call it that. But ultimately, we have some like principal Acumatica developers high on the top part of Acumatica that wants to have things branched out where you have a specific branch for each version of it. But if you do use conditional compilation, there is a way that you can minimize the amount of branches that you need. And at the end of the process, you really only need to merge things into a single main branch if you do conditional compilation right. And there's other ways that you can get to the same benefit of having a what you would think of as a branch for that specific version. So conditional compilation itself is a pretty simple topic. We don't need a whole hour to really discuss it. So what we wanted to do was kind of also add in and talk about branch management in general, because this is a technique. Conditional compilation is a technique that you can use to do branch management and minimize the number of branches. So, I mean, in terms of my training, in terms of leveraging source control, I've been taught by and been brought into the school of thought that less is more when it comes to branches. That the fewer branches that you have to manage, the less complicated and the less time you're going to need to maintain all of the branches that are open. And generally, the branch management process, you 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 have to open up branches to do your development process. You never ever want to do main development on your main branch. Bad idea. Don't do it. Generally, the process is when you need to add in a feature, you're going to open up a branch, do the work that you need to do on that branch, and then once it's gone through a QA process and it's been checked and everything's copacetic, then you consider merging that into the main branch. And there's a lot of variables involved in how you're going to do branch management based on the size of the project and also how many developers you're going to have working on that that project. In a lot of cases, with VAR development, you're working with small projects. You're working with a single developer, and there isn't anyone else in there to conflict with your work. So branch management in that paradigm can be pretty simple. You just open up a feature branch, you do your work on it, and then you push that feature into the main branch once everything is said and done. Well, when you start scaling up, and as you scale up to larger projects, you need a more complex branching structure. And so that's where you're going to have teams involved, and you're going to have more than one developer, one or two or more developers working on the same project. This is when you need to start using more complex branching structures, where you would have what's called a release branch or a sprint branch. Generally, if you start getting and talking about Scrum, you're going to need to open up. You're going to work on an iteration. You're going to have multiple features that you're going to push into an iteration. In those particular cases, you open up a release branch, and then you open up feature branches from there to do the individual work, and then that gets merged into the release branch. Once you're at the end of the iteration or at the end of the sprint, that process gets QA'd, and then that gets merged into the main branch at the end. But there's this common strategy that you do see a lot of Acumatica projects having, where you look at a repository, and at Net at Work we have a whole I was brought in, and I have about 30 repositories that we need to manage, and I see all forms of strategies in terms of this branch management. But there tends to be this you'll see 22R2, 22R1, 21R2, 21R2, and you have these branches that are just left open indefinitely, and then when you do your coding, now you got to merge all of that stuff into that branch. And my stance is that strategy is more time consuming, and you tend to spend more time working off of that type of model. And there might be good reason for you to work off that model. And a lot of people generally, you're going to have people chime in on that counter argument on here, because it's been a pretty good discussion to where a lot of what's the word I'm looking for, contrary thoughts on the subject are, and they feel that there is value in doing that. But I come from the school of thought that less is more. The fewer branches you need to deal with, the less time you're going to need to maintain that branch. Hence, the reason that conditional compilation works to help minimize the amount of branch structure that you have. I do have I'm going to share my screen real quick and just show just a quick pseudocode of what you might see in terms of how we would use conditional compilation. And there's been, so one of the counter arguments that you have in terms of using conditional compilation is like, oh, well, it might be, it can get a bit messy and whatnot. I would argue against that. I would actually say that it's actually makes things more readable. You have a single branch at the end of the day where you have all of this stuff organized. Whereas, okay, if you don't if you're maintaining these main branch version branches, I like to call them, then you got to move and you got different sets of code on all of these branches, and it's just very hard to keep your head wrapped around what really needs to be done. So in most cases, you're not even going to need conditional compilation. In terms of the vast, a good chunk of VAR projects that you have out there in the wild, you have a single customer that's on it. You just need to keep that customer on the current version. You don't need to maintain multiple versions. But once you get into IP and ISV product and needing to maintain and have things continue to work on various different versions of Acumatica, conditional compilation is a very good thing to consider. So, and very often than not, a lot of our places and part of the reason I'm showing you this instead of actual code is, I mean, I'm under NDA. I can't show you net at work code or some of the examples. And I just needed to pull something together quick to just kind of connote what conditional compilation looks like. So essentially what you're going to find in a lot of cases is there's going to be a single line of code somewhere in your class that is, once you move on to another version, let's say 22R2, Acumatica has made a change to the schema of things, and you now need a slightly different version of that code for 22R2 than you did for the previous versions that you're maintaining. So more often than not, it's just a single line of code that changes. So let's say this is whatever code it was that works on a previous line, and now you're wiring it up to 22R2, and now you just have something that breaks. You wire it up, your reference points to additional to the newest DLL libraries, and you need a different version of that line. So this is where you would wrap it into, and as you can see, it's just an if logic bracket. So what we're saying here is, if we're on these older versions of Acumatica, use this line of code. But if we're on a version other than that, generally you want your new code in the else if, because what happens is when 23R1 comes along, chances are this new line of code is what you need to continue to make your product work. So you don't have to write any new codes to make it work for 23R1, or when 23R2 comes around, again, chances are this line of code is going to work for you. Anybody that knows me knows that I am a stickler when it comes to commentary. Acumatica has actually given me the Scribe Award as a result of the commentary that I have in here. But one of the most important things that you need in here, so I mean this section here, I mean it tells you what the code is doing. It's saying, hey, this version, we're going to use that line of code. Other versions use that line of code. But what's exceptionally important is explain your whys. Always in your commentary, never explain your whats. Your code should explain what your code is doing. You want to do why. And in this case, it could be Acumatica's changed the schema. The previous field was named such and such, and the new field is such and such. So when it comes down to that argument of, well, it's messy code, it's really not, because when you look and read this section of code, you have everything that you need to understand why this is in place. And in the end, generally what's going to happen is once these versions phase out, generally you're going to be working on just the versions that Acumatica is supporting. But once you get to the point where you're no longer supporting those, you just drop that code out, and all this is the line of code that's going to be there at the end. But it just gives you the means of being able to have a single branch for all of this, and you don't need a version branch. Now let's talk to
Before we move,
yeah.
on, Sergey's had his hand up for a little bit. Let's open up a couple just so people can ask
Okay. Yeah, I know it's been a monologue
questions.
so far. So
Yeah,
yeah, let's
no, it's
get
great because I think you've set up, so people have an understanding about, why you favor this particular method. Hey, Sergey. So Sergey, you had a question. Why don't you go ahead?
Hi, Mark. Hi, everyone. Do you hear me?
yes, we
Yes.
hear you.
Okay. Hi, Robert. Thank you for your presentation so far. But I have two questions.
Hmm.
The first one is, did you try the approach with when you use reflection instead of conditional compilation? So I can see at least three approaches to working with multiple Acumatica versions. Like you can use Git branches for each version. You can use conditional compilation, but you can also try to use reflection and try to figure out in code what version of Acumatica you use and work accordingly. Work with what you find out. I have used this approach with the reflection in at least one customization, and also I use the same approach with Acuminator 2 because Visual Studio also have different versions and its API changes significantly between them.
So if I'm understanding the question right, you've got some areas where you're using reflection, you're digging into the DLL package itself, and then you're determining what
Yes.
version is actively
Yes,
being
yes,
used for
it,
that.
yes. For a simple example, let's, for example, there can be an API that was changed, like it could be the signature could change between two Acumatica major releases, and you can just try to figure out you can find out the type. It's actually not could be not that difficult because if both versions you want to support have the same type, you can just reference it in code, like type of API invoice, for example, and then you can get its properties or fields, take a look, try to find if there is the field you want to use, and if there is such field, then maybe it's one version. If there is no such field, then maybe it's another version, and work with that. And it's the same for functionality, like you can try to get some service from Acumatica and then try to check if there is the service you requested, or if there is no service, something like that.
Hmm. I mean, if reflection works, I'm not exactly sure. Like one of the use cases that I used in terms of describing this is like schema changes and whatnot. If you're digging in with reflection to determine versioning, you're still if you have code that's pointing to a previous schema, it's still not going to compile when you point it to another. But one of the
Yeah.
things that like what comes out of that question too is I would actually consider use conditional compilation as a last resort. When we discussed this in our previous MVP meeting, there was a good point that was brought up. I believe it was by Dimitri, and there was a thought like of controlling feature sets with conditional compilation. You really don't want to do that. Like conditional compilation is not a substitute for structuring your code in a good way. Conditional compilation is there for when the Acumatica code base has changed, and you need to accommodate that change and have a slightly different version of your code at the end of the process. So if reflection works and it makes sense to you, and generally, like you as a developer, like as long as you're able to understand it at the end of the day and your team understands the strategy at the end of the day, that's probably going to be the best solution. At the end of the day, it's like as long as the code works, that's the most important thing.
I
Did
see.
that answer your question?
Yes, thank you. And I also have the second question about the unit testing. So, how do you use unit tests with conditional compilation to test for everything?
Same thing happens essentially with unit testing. You would have some conditionals. You would use the same conditionals. It would actually send, and more often than not, you don't need the conditional compilation in your unit tests. But when you code your project in a way where you're pointing to a specific product, essentially what this is doing is if this is just a true false expression. If it's true, then the compiler is going to completely ignore this code here. But if it's true, it's going to go through that. So really, your unit tests are just going to work out of the box just as long as you got your project coded fine.
Yes, but I mean, do you have some additional automation scripts for running unit tests for all possible for all possible preprocessor symbols? Like you have symbols in the code you have
Mm-hmm.
shown on the screen, and do you automate unit tests run to run tests for all combinations of all possible values of such symbols?
Mm-hmm. And I have used in the past. I don't do it all that often, but I've actually got switches that I'll put in there that will add a means to do a unit test to a class that you don't necessarily have to have in production code. So you say, okay, well, we need because you can't get into a private member, for example, within a unit test
Yes, yes.
itself. But there might be, you're working on something, and if you're doing test-driven development, you might need to activate that private member via there. In terms of the production code, you don't want that private member to be exposed as anything public, but you can leverage the concept of conditional compilations to get a unit test to activate that private member without having to make it public.
Yes.
And I've used that mainly as kind of a last resort too. Like it's not a common practice on my end to do anything like that, but that that gets into another reason why you would use conditional compilation is for debugging purposes. Generally, when you're hitting your project with a lot of um, trace messages or performance counters or whatever it is that you need to do to debug and test out your code. Though that's all going to be a performance hit if it gets into a production system, and you don't need that extra code in there. So what you can do is you could decorate that debug code, those trace messages, your performance counters, all those sorts of things, and set it into a debug flag. And then when you're done with debugging, I mean, generally, if you want to be as clean as possible, you're just going to remove all of your debug code. But one of the things that I like to do is, hey, if there's a problem in the near future, I might want to just keep this here for just a little bit. So I like to incubate code for just a little bit before I completely remove it. So I'll put in like in justification, and I'll put in a little note to do after this date, remove this this code here. But that's a way that you could control it so that when you're ready to compile the production version of it, you could completely strip out all of that debugging stuff, but keep it there just in case you need to continue to debug
Yes,
stuff. And then
you probably use conditional attributes a lot, if I understand correctly.
That debugging stuff, generally that gets slated to be pulled out. Debug code, I don't want to keep it in the code base for very long. I'll incubate it for like 3 months if I don't have a problem with that class and I don't need that debugging
Yes,
stuff. It gets stripped out.
I understand. I mean, just in case there is conditional attributes, if I believe in system debugging namespace, when you place it on a method that just returns void, nothing, it will be added during debug in the debug build, but it will be removed by the compiler when you compile release build automatically.
That's correct. Yeah.
Yeah.
So you could consider that code just not being there on the production system.
Yes, but my question was about automation of tests for different configurations. So you have simple for Acumatica 2022 R2, 2022 R1, for example, and you want, before release, you want to run tests for all possible configuration to see that everything works for all possible Acumatica versions. So do you
So
do?
this is where you would have to pull in some DevOps strategies, because essentially you need to, and actually that was part of like some of my PowerShell session, was talking to that strategy in of itself, where okay, I need to build 4 distinct versions of Acumatica, and then I was working on a PowerShell script that iterates through all of those and then builds 4 distinct packages with appropriate references, and then each of those gets sent into their respective pipeline to then be tested.
I see. Thank you. That's
So let's move on to Tony. I'm excited to get Tony involved here. So Tony, unmute, because in our last call, Tony had some really great thoughts on this and some counter arguments, and he showed and shared with us, their strategy for their company in developing code. So Tony, how's it going?
Hey guys, I think Brian was first though. Did you have anything to add?
Yeah, he
Brian?
dropped off. Maybe
he
his
dropped
question.
off. Okay.
He dropped off. I
Just
think he
wanted
was
to make
like,
sure.
"Oh, Tony's on there. I should yield to Tony."
Regarding the current discussion going on, I just wanted to mention a couple things. The idea of using reflection as an option is a good one. I don't often use, but it's also a good option for doing what we're talking about. The only thing I would shy away from is that execution, that evaluation happens at runtime, of course. So that's going to, however minimal it's going to slow it down, it'll still slow it down because you're doing reflection and you're doing it runtime. So I'm sure there's some cases where that would be powerful to use instead, but that's just a comment. And I was just going to mention to Robert, I don't know if everybody in the audience knows how to create a constant or not. Maybe that might be something you might want to show them.
This is well, one of the things is I wanted to do a blog article and get my MVP quota taken care of with this. And
Okay.
I was telling Mark, like, and I've been telling Mark this for a long time. It's like, okay, I need to prepare. I can't demonstrate with net at work code and such.
Oh, that's fine.
But
we
yeah,
can postpone that then.
So there is going to be a forthcoming blog article on it. In my PowerShell scripts, I actually do touch on it, and I do have some of that documented out, particularly the last one that I've done, where I do point out where that code is, and all it is just a and if I wasn't having technical where was I going with that? So I'll get that pointed out. And so there's a place like in your preferences screen, like if you go and you right click preferences, you're going to see a place where you can specify those codes. And then that's all that you need to do. So when it comes down to like, oh, I need to build this package for this other version, you just change up your references and you flip that code. And what's really cool is like when you start seeing what happens with the conditional compilation, because you see like the part that's ignored, it all grays out, and then the code that's going to be acknowledged becomes active. So this is something that I want to also demonstrate, because like talking about this is just like it doesn't really help out as much. But I've been promising Mark that we've got to do this, so we decided we're just gonna do it. We'll just be extemporaneous. We're not going to have any slides. It's going to be a discussion. But that blog is forthcoming. That will be the next blog that I write. I will articulate my thoughts on why conditional compilation works in certain paradigms. But the thing is too, like there's always more than one way to skin a cat in terms of development. There's so many different ways you can do the same thing. It's just a tool that you can add in your tool belt, and it's actually really simple. And one of the things, and I would say that it's because it is simpler than reflection. Like reflection's a pretty heavy topic. I mean, I get it. A lot of other developers on the call, they get it, but it's not the easiest concept to get your head wrapped around. Conditional compilation, on the other hand, it's easier to get your head wrapped around, I would say, and simplicity goes a long way in terms of maintaining software.
Yeah. So Tony,
yeah, I'll jump back in.
Yeah. So Tony, will you share your screen and show? Yeah, exactly what I wanted to see. Thank you. Yeah, I wanted to. So we did this a couple of weeks ago. We didn't record the call, but so yeah, Tony, why don't you explain the methods that you use with your company?
Yeah, absolutely. And I can probably make these diagrams public at some point, but I haven't yet. I created these a while back for our company, and I've been in the software configuration management world for many years, and sort of developed my thoughts on this along the way over the years. And honestly, Robert and I's opinions aren't that different. He explained all the different options and scenarios and purposes for different uses of branching and versus conditional compilation, etc. So what I've done here, and I'll just go through fairly quickly, is diagram out some of the branch scenarios that we use and that are actually fairly common in the industry and software development in general. So this first diagram here on top, what I call feature branch, we use the most often. We are a var, actions of var. So typically the changes we make are one-offs that, add fields, add screens, add something, so it's not an entire application. We do get a percentage of work that's larger and may require more branching, but for the purpose of just one client, one change, this is sort of the scenario we typically use. So in our source control system, which we use DevOps, Azure DevOps, we always start out with a master branch. And as you'll see in my diagrams here, what's common is that master branch, some people call it main, we call it master branch, stays fairly flat. That's one of the objectives that we have is something Robert was talking about. It can get too complex if you've got so many branches going off in different directions and they're never ending. You don't know what's what. So the idea here is one of the objectives is to always try to flatten it. When you release something, merge it back into master. So like I said, here's just a quick feature. We want to create a code extension in Acumatica. We branch off, work on it, release it, and merge it back into master. That's as simple as you can pretty much get.
Mm-hmm.
You can take it further, this lower diagram, and you could even branch per developer, per user that's doing development, if that's something you want to do, or if multiple users are working on the same feature but they want to be isolated, etc. You can take that further. And so Robert is saying less is more. Often I agree, but at the same time it depends on the size of the solution, right? So if you're just doing one-offs, it's good to keep it small and merge back into master. So here's just more examples of the same thing. So this particular piece of code or component or application, there's multiple features being developed at the same time. You don't want to work on the same branch and affect each other. Isolation is the key in all of this. Very, very important to isolate your own work, the features work, etc., so that you're not stepping on each other's toes. So in this case, it's fairly easy to follow this. Feature branch is being worked on. When it's released, it goes back into master. And in this scenario, this feature now needs the other features changes, so it'll pull it and merge it into its own branch, and then eventually merges back into master. So that's another key, is to keeping master as flat as possible.
And if I may, I'd like to add, like, this diagram is like a perfect example of one of the major common problems that you have when you're working with multiple developers. And this reflects what I would call a refresh merge. So you see how the top part of that diagram goes. You have one user branching off from the main, and they're making something work, right? Well, we got the bottom guy. He's working on something different. It's taking a little bit longer, but what the top guy's now finished with his work. He's merged his stuff into the main branch, But what often happens if you're working in a multi developer type paradigm is that that bottom guy he might be unaware of the work that the top guy did, and he might push something out what he's finished. So now you have two complete different packages. That one feature A is in one of those packages, feature B is in the other one of those packages. And what you need at the end of the day is you need both features in the same package. So you have that what's called that refresh merge. That's that merge that's going into the bottom guy's work.
Yeah.
He finishes his work. Now when he merges it back in, everything is copacetic because now you're not wasting anybody's time because nobody's finding a bug that hey, I'm missing this feature on this package and then I'm missing a feature on that package, and it just saves a lot of time. So that part of the diagram, like that's one of the things that I wanted to get articulated in this. And I'm sorry to interrupt. I just needed to get that out.
No, it's fine. That's good points. Absolutely. Along that line, though, when this happens, when there's branching out and work happening on different branches, if one, the key, another key here is this master branch, in my scenarios anyway, follow an actual release build. And I'll show that in a second. But so this merge would only happen after testing and after pull request and somebody approving it, and then it gets put back into master when it matches release. So yes, absolutely. If this second feature is going on, they have to be aware of when a release happens, and then they need to pull that into their own branch and move forward. But yeah, good points. And this just shows a simple idea of a release branch. If some people, instead of single features, they may decide to do an entire release branch and then do features off of that. Show you more of that. And this shows more of that. I'll move a little quicker here. But this just shows what I was just talking about. If you have a specific release, you can name it as such, and then build features off of that. And that way, what's actually in production can differ from the major release you're working on. So the other stuff just shows some ideas of if a release is progressing and while it's being tested, for example, an issue occurs, you can branch off to fix it and then merge it back into the release branch.
Yeah.
And this one just shows, hot fixes. If it's already in production, you can branch off a hot fix and merge it back in after tested.
Yeah.
We didn't get into CI a lot, but I have some basic diagrams for that too. For example, let's tell you what, let me move on to my putting it all together slide.
Nice.
It's a big example, basically, of what could happen. So here I'm showing two features going on at once, as I showed you before, branching back into master. At some point, you decide to create a release branch and work off of that. That's what this line is. And then as far as CI goes, the idea here is setting up multiple pipelines where if you have a dev test environment, you can set up and automate builds so that when something is checked in or pushed in, it can be automatically built, labeled, etc. And that pipeline goes on as long as the release build progresses. And this just shows some other examples. What if a second release, like minor release needs to start before this release branch is complete, and it just shows you kicking off another test pipeline for that. And as well as additional pipelines for when you actually get into UAT or testing or production. And you typically don't want to automate those. You want to manually trigger those because people are inside those and working and testing, etc. So that is a high level of different types of branching and CI scenarios that I've diagrammed. And it really doesn't conflict with what Robert said. It's just different scenarios that need different options. When you're working on the smaller changes, it makes sense to do small branching. But if you're working on the bigger products, or if you're an ISV developing on something large, it makes sense. You may need more complex branching with release branching and user branching, etc.
Yeah, and I do have some stuff to add, but there's quite a few people with hands up, and
Yeah,
I
so we're going
don't
to
want
move to that. But
to.
first, I just want to say really beautiful diagrams.
Yeah,
I'm sure people on the call, or when this gets published out and more people see this, it's like, oh, I would love to have these beautiful diagrams. So if you can make that public, I think people would appreciate it.
Yeah.
So
I'll
let's
send it
let's
to
go
you
to
at least,
Brian,
Mark.
because Brian had his hand up earlier and then he took himself out of the game. So he's back again. So hey, Brian, what's up?
Oh, I was just sitting here thinking how wonderful this is. I heard Tony at the beginning say, I'm sure I can make these public. And I'm looking at the screen going, Tony, you just did.
If you
I'd like
want
to
to
step
video,
back.
yeah.
Branching is great. I'd like to step back up to much earlier. We were talking about conditional compilation and preprocessors. And I'm actually going to go way back because for me, I worked in a legacy system. We used Progress 4GL. And preprocessors were a thing that we didn't use a whole lot, but it had a great purpose. And I think that there's been a lot of great conversation here about conditional compilation and some of the benefits of using it and not using it. I'd really like to harp on the comment, and I forget who made the statement. It may have been Robert, but or it may have been Tony. I'm not sure. But when you don't use a preprocessor, so for conditional compilation, it's called conditional compilation for a reason. Because if you've negated that code from being compiled, it's not going to be in the DLL, which means it's not going to bloat your code, which means it's not going to execute, which means you're not going to slow things down. Now I'm going to date myself for a second. Back in college, we had a computer lab of 386. That would be the Intel 8386 for the newer folks that need to go look up what that actually means. That's the precursor to the precursor to the precursor, about 12 generations before we ever got to the Intel I series processor, right? So back in those days,
back in the 80s.
no, it was actually the beginning of the 90s, but yes.
Well, it was
in that
80, 89, 88.
For me, college started in 90. So, but we
Yeah,
had a
but
lab.
they had that architecture out in the
They
80s.
did.
Yes.
So
because I used to
had
manage computer lands and we sold them.
we had the 386 computers in the lab, and those things did not move very fast compared to modern technology. Obviously, my first hard drive that I built on a computer or built a computer with it was a 10 megabyte MFM hard drive. I now carry a 256 gigabyte stick in my pocket, in my little coin pouch. So technology has advanced dramatically, but I grew up in an era where it was very important watching clock cycles and how much data you were going to consume and how much network bandwidth you're going to deal with. So, we had the 1200 baud or the 2400 baud modems to contend with if you wanted to move data. So fortunately, I didn't have the one you had to put the phone on the receiver kind of a thing. But I saw somebody say, this was my first modem. It was a 56K or 57, whatever K modem. Going, I was using the 2400 baud modem and couldn't move data. But the point being, in that era, we learned it's all about performance. It's all about making things as tight as you can. When I do a debug today and I look at how many times my record is pulled again from the database, I cringe just because I know I need to go pull that record one time, get it in memory, work with it, and if I need to push a change, push it, because the amount of resources it takes, both in the server itself, in my computer, in the network between them, all of those things are being bottled up into this big old bundle of stuff that's competing with those same resources for my neighbor's bundle of stuff, and then 3 states over, their bundle of stuff. And so it's very important to be able to get things very concise. And preprocessors and conditional compilation really play into that to let us keep bringing it together and keep that amount of information put together very small. With that, a couple of applications. One, I believe you had mentioned about the debug messages. I love debug messages because I need to know what's happening, but I don't like for them to actually accidentally fall through and my end users actually see my debug messages in trace. So that's a place where I like to put messages in. I actually like to leave them in code because in my environment, I'm a sole developer. So I like to be able to go back and look at what I did because I'm getting up there in age now. So I don't remember what I did yesterday. Leaving it there helps me. So when I tried it and it didn't work, I like to go back and be able to see this does not work. Don't do this. This has a problem. Also, again, I work for a company, for a private company that we write our software for us. So that code, I'm working with a sysadmin that says, hey, let's change this behavior so it works this way. And I know full well next week he's going to say, I don't really like that. Can we go back to how we did it before? And I don't want to have to go try to figure out all the places in the repository that we unfortunately don't use yet, but I'm working on it. But I don't need to go back into all of my archives to find out where all the different files were. If I'm using a preprocessor, which I haven't thought about until you brought this topic up, which is why I'm very thankful, then we have the ability to have that code set up so that if I want to have something experimental that we try and I can pass it to them and I can easily remove it, this is a great tool for me to do that. So when I have a block of code, and I've got a block of code right here that says this is how the system behaves today, and I want to negate that, today what I do is I comment it out and I make another copy of it. And then I have to go back and make sure I'm uncommenting the right stuff and removing the things. I think it's very messy and very dangerous. And I do have problems sometimes making sure I hit all the points. But if I use a preprocessor, as you've enlightened me today, the way that we used to use with our old legacy system, I can actually comment that out with a preprocessor that I just flip a switch and say, try it. And I get to try my new code. And if I don't like its behavior, flip the switch, go back to the other code and make sure that what I think is the problem is really where the problem is. Because my history is every time I have a problem that I don't get right away, it turns out it's always misdirection. I think it's right here, but it turns out it's all the way over here. So great ways that conditional compilation can be very, very helpful and very powerful. And I thank you very much for enlightening me on that because I used it a good bit in my legacy days, but in the few years I've been doing C# development, I never thought to ask. So thank you very much, Robert.
I appreciate that that validation, Stephen. I really do, and I have some additional comments on performance to build off of what you just said. But we got people in queue with questions, and I don't want to
Well, you
hog
can say it after.
the
Let's get
mic. Yeah.
Marco in on the commenting. So Marco, you'll need to unmute yourself.
Yeah. Yes. Thank you, Mark. I'm actually going to go back to the different branch strategies that I believe Tony was sharing. For any other developers that are currently using that strategy with branching before they decide to start using other tools like conditional compilation, I'm curious about how your team is managing different in our industry with different Acumatica versions. So you have like a master branch and then you have release branches. And how do you handle your master branch regarding the different Acumatica versions? Do you have like the master is the the oldest Acumatica version you support, and then you upgrade and keep it master like that, and add newer versions as releases, or how do you map those different versions to your branching strategy?
Is that question to me or Tony?
To Tony. To Tony.
Okay.
So yeah,
But
this is
anyone that can share their own strategy is useful. Thanks.
yeah, anybody can jump in. This is what I showed last time we talked. I guess I didn't today. When we talk about versioning in the other examples I gave for releases, that was based on internal version. But when you talk about different Acumatica versions, my ideas around this are similar. So you can name a release off of the Acumatica version. And you can see this was done a while ago because it's version 19, right? But
Yeah.
Right.
that's the idea. So if you know that you need to create a customization for this release that's out or coming up, you can branch off for that. And then you have the normal scenario where you're branching features off of that while the pipeline's progressing, etc. And then if the following minor or major release happens, go ahead and branch off of that one. And then those eventually get merged back in based on the timeline. And or if you need to support both for a while, those different release branches can continue until Acumatica versions merge together.
So one thing I want to go ahead,
Yeah,
Marco.
Yeah,
And
just
I'll just
sorry,
add one more thing real quick I didn't show. Another sort of abstract scenario is, what if you have code that's common across clients, across projects? And the idea here, if I have this project release down here at the bottom, and I have a common component that's being used across clients, the only thing I'm really showing here is the ability to pull that in across repositories using NuGet, etc., so that you can share that common component with multiple clients. Sorry, go ahead.
Right. Yeah, well, I just wanted to add, we have a similar strategy, and in our case, we have different branches for each Acumatica version, and our master branch in that sense is not really that much used. We just updated with the latest, or the oldest one, right? So it just keeps upgrading. So it functions as the master, like a source, but we actually our working branches are more like the release branches. So I just wanted to hear about other strategies, but I think it's also similar to the way you handle it. So thank you, Robert.
Yeah.
You also have.
Yeah, and I think that kind of gets into like the original discussion that kind of prodded this to happen 2 years later, because we had this discussion with the surveys project, and I'm glad we have this screen on here. So what I do see a lot, and we have projects on our side that do that are structured this way, but we are moving to a conditional compilation, is you have these version branches, but they're kept open indefinitely. They don't resolve. You keep your versions in each of them, and then you do some change, and then you start merging them into all of the other version branches. So essentially, each of those version branches are their own pseudo master branch in a sense. So I've seen that, and in my case, I find it less time consuming to maintain those changes across different versions using conditional compilation, as opposed to, okay, we have this change now. Now I got to push it into all of these other version branches that we maintain. I would say that process is probably more error prone, and it gives and as soon as you have that human mistake where something was missed, where it didn't get into one of these previous other version branches, and then that ships off, and then there's a problem, you've just lost. It's a chunk of time that's lost. But if you get your code structured in a way where you're using conditional compilation to say, I need this version for this release of this version of Acumatica, and I need this version of the code for that version of Acumatica. When it comes down to building and bringing those new features into other branches or other versions of Acumatica, it's just a matter of flipping that switch, and all your code is in there. So that's kind of what really spawns the whole conversation and where we wanted to go with this, like a couple years ago. And because we had that, we were thinking about that. It's like during the surveys project, okay, we got to maintain this for other versions, and we did structure it in that where we have those branches opened indefinitely. So just my thoughts on that. But this diagram here, it shows, well, you're opening a release branch for a version of Acumatica. A whole bunch of work is done on it, but it merges into the main branch. Then you proceed on. Another version of Acumatica comes out. Then you branch off. You do all of your work on that. But at the end of the process, it all merges back into the master branch. There's hasn't been a diagram yet that really reflects what's going on with keeping those version branches open indefinitely.
Something I didn't mention on here is these are labeled as well. So for example, this one you can pull out by label easily once it's merged in. Same with this one.
And
here.
And that goes into your hot fix sort of thing. So what I think is a better strategy than using and keeping version branches open indefinitely is to use the topic of tags. And I think that's probably what you mean by the version of the labels. Different systems call them different things. I think GitHub and GitLab use the term tag. DevOps might use the term label, but nonetheless, they're the same thing.
Yep.
Essentially, when you build a build, what you can do at that point is you create a tag with that build number. And then that essentially gives you the ability to spawn a branch exactly with exactly the same code that was used to build up that version. So then you can branch off, do a hot fix off of that tag, and then figure out getting that merged back into place at the end of the day. You're on mute, Mark.
Yes, I am on mute. My dog was barking in the background. I just want to make sure you couldn't hear it. So, Yuri, you had your hand up, but then you just lowered it.
Yeah. Robert covered my question basically.
Awesome. Great. Another person I'd love to jump in here, and I call him out all the time, so hopefully he doesn't hate me. He keeps coming back, so I must not punish him too much. But Joshua, you're held in high regard for your branch management, and you're helping us on this new project that Brian and I and others on this call, the CMMS Lite project that we're doing. So I would just love to hear your commentary on what you've heard so far and kind of color things up a bit more with your erudite commentary.
Oh, goodness. Yeah. So, I mean, I would say everyone's expressing some really good ideas and processes in regards to how to manage code. And as people have touched upon, it really depends on the situation or like how your projects and your development teams work. So I'm Josh Van Hoosen. For those who don't know me, I'm the Director of Engineering at ASI LLC. We created Nonprofit Plus, which is the largest embedded solution within Acumatica. So we've got over 40,000 lines of code that extend to Acumatica functionality, and we've got a development team of 9 individuals, all of whom touch the code at one point or another during the course of their day, week, and sprint. So I'll share my screen and kind of explain a little bit in regards to how we do it. I want to share the screen, not the window, because I always hate doing that. Okay, great, awesome. So branching. So we've got 3 main branches that we have here at ASI. They are master, development, and testing. So master is the release builds. So release build only ever comes from master. Testing is the work that we have done, merged into development, and is now being tested for release. So our pull requests usually will look as a feature branch or an update branch. We also have a bug fix branch. So everything on our side is either a feature, an update, or a bug fix. These numbers you see at the beginning of them are numbers that are tagged to particular tasks within our project management system. So we use Asana. And so every time we create a task, it auto-generates a number. We utilize that number when we're creating the PRs. That way they're easy to find, not just from like a commit log numbering sequence, but also as a tie back like into the project management system. So we'll do our work. So a developer will typically, especially if it's like a feature, you create the branch and then you create a copy of the database that you're doing the work on it, and we post fix it with the branch number. So if we're looking at our development server internally, you'll see the project name, the major minor build, and then the task number that is being worked on in regards to that. And once the task is complete, that database goes away. But one thing that's really important to remember when we're doing Acumatica work, especially in a shared environment, is certain things are stored in the database. So even if you have separate code, if you're sharing a database during development, you could step on one another's toes. So that includes things like schemas, generic inquiries, endpoints for API, specifically REST. So you always want to be mindful and careful of things like that. So we create the separate branches, both from like a database perspective as well as a coding perspective. So then once you're in your branch, everyone does their work. Yay, fun times all around. And then we create the actual pull request. So a pull request requires 2 approvers on our side of things. So you can see like this was a pull request that was an update. We added a functionality that we call event codes to fixed assets. And so it had to go through approval before it was then merged into development. We require at least 2 approvals. Can't be the person who did the work, obviously. And it's usually any general developer and also one of our senior devs. And then we also have an internal checklist. So whenever you're doing code reviews, there's specific things that you are looking for. A lot of it is formatting, in all honesty. And then so it goes through. People make their comments, searches outside of if statements, formatting, functionality. We're also big on commenting. I know some of the other developers touched on that. So this is an example of some code that we were overriding the reverse invoice process for Acumatica. So, we've commented that this is an Acumatica overridden method. We need to review it when we do the upgrade from one version to another, because Acumatica does make changes. And though I'm sure they try and be good, as every developer does, sometimes they don't necessarily document everything as well as we would like. So it's always good to review. Yeah, so it's always good to review the code. So, obviously make good comments, things regarding that. Now, when it comes to like Acumatica versions, so major and minor builds, or major builds we have in separate repositories. So we use DevOps Online, so that's through Microsoft. So we can create separate repos under the same project. What that allows us to do, which kind of saves some work, is we do what's known as rebases up from one repository to another. So if we implement a feature, we tend to implement it in the lowest version that we support, and then we just rebase that functionality up to the highest version that we support.
How is that executed exactly?
Tedious, well-documented process on our end.
Is it automated?
It's not automated yet. It's something that we're working on to tie up a lot of our processes in an automated fashion. Currently, we actually just shifted from batch files, which we utilized to shift some files around, so they were within our repository. Because that's another important thing that I think all developers should do if they're maintaining a repository system for a project, is make sure that the package itself is included within your repo. So within the customization project manager, you can actually save source control from that project, and it will, instead of exporting like a zip file, it'll give you just a file. Well, it is a zip file, but then you unpack it. It's a file folder that has all of the XML files that express what that customization package is. So like all the modifications to GIs, endpoints, tables, everything that's not your code per se. You should also save that in your repo. And then that way, if your database ever dies a fiery death, you can just pull down the files from the repo and reconstitute your package, and it's not an issue. Okay, so I've covered branching to a degree. Okay, right. So once then we've done all of our development work, we will do a pull request from our development branch into testing. So you can see one right here. So that'll take all the work that we've done. We then do a pull down the testing branch on one of our, Visual Studios. We rebuild, and then that package goes to our testing individual. And we assign all the tasks that were associated to the pull requests associated to this deployment. And then we'll do two things. So he does specific functionality testing. So he'll run through each task and test. And then we actually use the Selenium testing bot that Acumatica utilizes as well. And we'll do a full suite of testing of our functionality in regards to that. Because sometimes you make a change and it has unintended consequences. And so a robust automated testing framework, no matter how you do it, unit testing or otherwise, helps prevent those sorts of things, making it client side, which I'm sure, the business side of
especially
things
with
always
ISV.
appreciates. Right. So then once it goes through testing and is approved and clears, then we'll do a pull request into our master branch. So you can see here the package number 2 was approved. And then we'll do the deployment from there onto our customer portal. So then our resellers and customers and individuals can download the newest version. And then what we tend to do, so we're not supporting 50,000 versions of Acumatica in regards to minor builds, is we'll do a force up methodology. So if a client runs into an issue that breaks their business process for them that needs to be fixed on the Acumatica side of things, we'll then upgrade our code base to that version and require all of our other clients to upgrade to that version as well. So we're not supporting every little minor version in between there. We're just supporting the ones that break things, or that fix things that break things.
One of the things that I wanted to add in terms of your experience here is, like, very early on when we started talking about this in the surveys project, we looped in other Acumatica developers, and And Evgeny Afanasev chimed in terms of his opinion on it, because he sees all of the ISV stuff that comes in, and the question was like, how often do you actually see conditional compilation in the ISV code? And one of the things that he commented on is that generally for some of the smaller stuff, you'll see it more often. But his stance was like, okay, depending on the size of the project, conditional compilation is good in some cases, and it's not so good in other cases. And one of the cases was on larger projects, and you're the largest project out there in the ISV market there. So he's pretty much saying that for larger stuff, the conditional compilation stuff kind of falls apart in those particular cases. And it kind of sounds like that's the case, because you're keeping distinct repositories themselves for each of the major versions, if I understood you correctly.
Yep, that is correct. Okay, so I guess that's kind of my rambling at the moment. Does anyone have any questions, comments?
I just like that you brought up the adding the package contents to the repositories. It's something very simple that not all developers are aware of, and I think that it's a good practice to handle those files and contents in every repository as part of the version management.
And that's actually something that I wanted to add on to, in terms of like conditional compilation versus like other not. So conditional compilation, it works in terms of your C# code. You can put in those pragma statements and add a switch, change how your C# code is going to work. It is not going to work in terms of your low code, no code package stuff. There's no way that you could get in there and do conditional compilation for that stuff. So in that particular, you got to have a strategy to be able to handle those sorts of things. In my experience, when we use conditional compilation in the C# end of things, we get fewer regression issues, and we get a general sense that the C# thing is a little more stable. Where we find that we get the majority of our regression issues is in that low code, no code stuff, the stuff that's in that customization package, that stuff that you can't conditionally compile. And the best strategy that we have on that, and I think Joshua also mentioned this, is just good process documentation. That's the best we can do in that particular case. So when we identify, hey, screens have changed, and on these versions, we need this particular screen definition in that low code, no code stuff, and we need this different version for that. We have a folder structure that we use to and a README documentation as to what's necessary to do to get and build different versions. So you got to have a person put the right file into place manually. I mean, we're thinking about getting some PowerShell scripts in there to kind of automate this process, but that's essentially one of the headaches that we have, is the regression that we get because we can't do conditional compilation on those types of files. So that could be a good reason why people do generally have these branches out there with these different versions, is to maintain specifically that problem.
Yep.
Right.
So we're going to
wrap up. The same goes
up
for dependencies, right?
Mm-hmm.
Sorry, Mark.
That's okay. I was just going to say we're going to wrap up, but I wanted to give other people on the call, which has dwindled quite a bit because we went over by a good chunk of time. I should probably schedule these in the future to 90 minutes. because when we get into a really good subject like this, we go over, and it's been really a great call. I was worried a little bit because we had such a great call a couple weeks ago in our MVP, and I was like, oh, I should have recorded it. But I really like the way this session has came together, and a nice healthy discussion, and I think people will have a better understanding of the different strategies available for branch management, and when not to use conditional compilation, and people that didn't even know what conditional compilation was and that it was available to them. So I mean, like for Brian, coming out of legacy development and so forth, and pre-processing, and I came from that as well because I'm also an older guy, and so yeah, it really resonates really well. But is there anyone on the call that just wants to make any comments? Was this a good session for you? Did you learn anything? Some of you that haven't commented, there's only a few of you left on the call, but I definitely want to give you a chance to chime in. So Jennifer, go ahead.
I just want to say this has been like hugely beneficial, but I haven't done coding with other programmers in probably 5 or 6 years. So I'm probably gonna have to watch this at least 7 more times before I'm gonna grasp a lot of what you guys were covering, but it was fantastic.
Oh, awesome. Good to hear that.
Yeah,
Anyone else on the call?
and there is a promise that a blog article is forthcoming that will get into more detail on the subject of conditional compilation. That is going to be my next.
I heard it, Mark. Nail them down to this year.
Yes.
It's going to be this year.
Well, what we can do is we can all gang up on it. It could just because it come from me, but the complete peer pressure of all the MVPs saying, Robert, you said we have you on tape. We got you on the video. We got you on YouTube. It's public. You've said it. So I'm curious, Dioris, I want to call you out a little bit because you used to work for Acumatica, and now you're working with Stefan, who wasn't on the call. Stefan was actually on the call a couple weeks ago. I just want to get your perspective because you like Sergey, you were Sergey's is a developer for Acumatica. You used to be a developer, and now you're working for someone else. Do you have any thoughts on all this? And you're muted, and hopefully you can give us some of your thoughts, being a very experienced Acumatica developer. You're unmuted, but I can't hear you in case you're talking. There we go. No, actually, Dioris. Dioris, before I let you speak. Dioris, are you trying to speak?
Hear me? Can you hear me, guys?
Yeah, now we can. So do you have any comments? And you've been here, I think, the whole time.
Hello?
Yes. Can you not hear us? Well, he's having technical difficulties.
Hello?
Yeah, we hear you.
Can hear you,
guys?
Yes.
Oh, man.
He can't hear us though. I'll have to edit this part out.
Hello?
I'll mute him for
Hello?
now. Sorry, Dioris, I had to mute you because you can't hear us. So, Sergey, you were gonna say something. So go ahead.
Yes, this was very interesting session. Personally, we have a complex branch strategy in Acumatica. So I wrote in the comments a bit about it. So we have to integrate between Jira, Bitbucket, and everything else. We have a very strict naming convention, both for branches and commit messages. And it is enforced by Git hooks on the server side. So it's interesting to hear about strategies that other people use, and also it's interesting to learn about conditional compilation because I have mostly I have seen it in the .NET source code, so not in didn't see it used outside of it. So that's everything was very practical, and I also wrote in the comments a bit about reflection-based approach. So some people mentioned that reflection can be slow, of course, but you know, Acumatica itself is built upon reflection. Everything like graph event handlers, decks, and most of Acumatica specific objects in platform extensions, graph extensions, cache extensions, they all are wired up using reflection, and it can be optimized significantly by using code generation, by caching the generated results. So I want to say that it's not that hard. If you have a simple scenario like you have, you just need to call some API that depends on Acumatica version. It's not that hard to do it using reflection. And even in performance critical scenarios, you can use code generation with several approaches. Actually, Acumatica uses almost all existing approaches to code generation in .NET. Like it generates intermediate language bytecode to wire up graph events, to wire up it generates a duck equality comparison at runtime. It uses link expression trees to collect graph and deck extensions and PX overrides. So it really relies.
Hello, guys. Can you hear me?
Yes. Can you hear us? Yeah, he has something on his side that he can't hear us for whatever reason. Strange. Anyway, Dioris, I'm going to mute you again.
Can you hear me?
Yeah, sorry. I muted you. We can hear you, but sorry. Sergey, go ahead. Continue your thoughts. Sorry about the interruption.
Okay, so basically what I wanted to say that it's not that hard. It's a common knowledge, so it's not Acumatica specific techniques. Therefore, there is a huge community. You can find a lot of examples on Stack Overflow. So it really depends on your goals. Because you know it's really if you have one package, some small or medium solution in one package, it can be much easier to to use reflection approach, because it allows you to support in one version of your package several versions of Acumatica. So there is it eliminates the need for several branches or for conditional compilation, which also results in several packages being compiled. But at the same time, it's for more complex things. It wouldn't be a solution. Like if you need some functionality that exists only in a newer version of Acumatica, and in general, we also use multiple Git branches. We don't have a master branch, a single master branch. We usually have each branch per release, but I think this is because we need to support and maintain several branches at once. So we maintain 4 major branches with 4 latest major releases of Acumatica. We keep actually, we maintain more than that. We maintain also branches for each minor upgrade, and we have version. We have a very strict policy about what can be pushed where. So usually we do not add any new features or any breaking changes into the already released branches, into already released major updates. Everything like that goes into the next major, and we have strict testing cases for that. So we have breaking changes test. Even if we break some API, some rarely used API, we still have to move it into the next major. We also have a strict review policy to enforce this. I mentioned Git hooks, but they mostly enforce naming conventions for integration. But we also have a big DevOps team and QA team. And the requirement I have seen in comments that someone, that Josh mentioned the requirements in pull requests. We have a requirement to have one QA engineer to approve the pull request. That means that all related tests have passed. And we have a requirement to have a senior team member, maybe team lead, and also the maintainer of the changed code. Like you change code in some area, you need to add the maintainer of that area. And also there is special person. The last one is the special person. It's like Andrew Bulanov or Sergei Shigin, our two directors of engineering, who approve or who give the final approve for each merge. So it's a bit more complex process because Acumatica is a much bigger solution, and we have a lot of developers that need to cooperate, and we have a lot of automation, like when you mention that sometimes you have problems with merging branches into the product. We also have such problems, but we have automation process called cascade branch in Git. It's automated, and it brings all changes from previous majors, like all bug fixes or that were added to the previous releases in minor updates. It automatically brings it to the next branches, like cascade merge. For example, 2021 R2 can be merged into 2022 R1, 2022 R2, and etc. So basically we do it like that, if it's interesting for you. And if you have some questions about our approach, you can ask. It was very interesting again to listen about your strategies. We use something similar for side projects, like something less like internal tools or Acuminator or some big customizations.
Yeah, that makes sense.
And I think that's in line with the comment that I made after Josh, that we had Evgeny Afanasev chime in on the topic, and it was a matter of the size of the project. Obviously, Acumatica itself is a ginormous project, and he mentioned that the larger the project is, the more conditional compilation kind of falls off the table as being the ideal solution. So I think we could conclude that at the end of the day, if the code works and you have strategy and your team is on board with whatever approach that you need to do to deliver quality software, as long as it works, that's the main thing at the end of the day. But different paradigms and different size projects and the volume of developers that you're going to have on there is all going to determine what your branching strategy is going to be. And then also, and at the end of the day, using reflection, using conditional compilation, using whatever techniques that you need to do to manage the process of maintaining multiple versions, as long as it works at the end of the day, I think you're good. So I think we're at the same point that we were before, where It's there's benefits going every way, and it's just understanding what those benefits are, and it's just a tool in your tool belt to solve a problem.
Yeah.
One of many different tools that you can use.
Yeah. Well, I
So
think, the reason we have Coffee and Code and we have these informal discussions is really it's about sharing different approaches, our thoughts. And I think everyone learns something new, right? Because we have our own processes and ways that we work and people have theirs. It's always nice to kind of get together, listen to people's, their perspectives, the approaches they have, and, things that you never thought of. You go, well, maybe in this case I should use this approach, or I didn't know that. Actually, this would be a better approach. So it just gives people, educates people on different ways in which people do their work. And in this case, how they manage, the branches that they do and their version control and, hot fixes and, all the things that you need to worry about in a DevOps environment. I think is very useful. So I think this is one of the better Coffee and Codes. I know you were hesitant and it's taken a little while to get you to do this, Robert, but I appreciate you spending the time. And it was great to have Tony on the call and his beautiful diagrams that really illustrated. So I think it really was nice and dovetailed in together. And then having Josh at the end as well, talk about their strategy and, being able to say, hey, we have the biggest solution on Acumatica. This is our approach, but then get the insight of Sergey Nikometarov, who's on the product team, to look at the approach. And, like he says, it was interesting to hear the different approaches here. So it's really nice because we got to hear different approaches, different perspectives from ISVs to VARs, and even Brian at the customer level by himself doing all this. Learning what he could learn from this and, the pre-processing world he came for way back in the legacy days to say, hey, conditional compilation is basically what I used to do. So I learned something and I can incorporate this into the work I do. So a lot of value here. I appreciate everyone coming together and sharing their thoughts. And I want to thank you. And I'm going to go ahead and end the session, but a great Coffee and Code session. Thank you, everyone, for your contributions today. It's very much appreciated. Until next time, we'll see you in our next Coffee and Code. Take care. Bye-bye.